Hi everybody, this is our last video on section 17 using the quadratic formula to solve quadratic functions for the zeros. So one method that will always work to solve ax squared plus bx plus c equals 0, and this is key, it has to equal 0, is the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Yes, this is a mouthful, and yes, it might be hard to remember. There is a song that you can sing it to. It goes to the tune of Pop Goes the Weasel. I am not the greatest singer, but I'll sing it for you here because sometimes having a tune for it to go to makes it adhere to your memory more. So here we go. Again, Pop Goes the Weasel. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So there is your quadratic formula in print and in song. And these A, B, and C are coming from A, B, and C from the quadratic function. I have to stress here, this is to solve when the quadratic equals 0. So it has to be set equal to 0 to use this method and to use the factoring method. Both of those methods require that the equation be set equal to 0. But if factoring doesn't work, if the square root method doesn't work, the quadratic formula will always work, okay? It'll still work. As a matter of fact, even if these methods do work, the quadratic formula will still work. So if you still have a hard time with factoring, if you have a hard time with the square root method, this will still get you the answer, okay? So you still have an algebraic technique to be able to get you the answer. So now let's see how it works. Use the quadratic formula to solve 3x squared plus 4x plus 1 equals 0. So first things first, I'm going to identify my A, B, and C values. I'm going to write and recite the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And now it's just a matter of substitution. But remember, we plug in with parentheses, okay? Remember from the beginning of the semester. So this would be negative 4 in parentheses plus or minus the square root of 4 in parentheses squared minus 4 times 3 times 1 all over 2 times 3. Now, the first thing that I recommend that you calculate is this piece underneath the square root sign. And we're going to talk about what that actually is called in a minute. But in terms of calculation, it's always going to be easier if you can get rid of this more complicated piece underneath the square root. So this you can put directly in your calculator. We want 4 squared, which is 16, minus, this turns out to be 12. So 16 minus 12 is going to be 4. So this winds up giving us negative 4 plus or minus the square root of 4 all over 6. The square root of 4 is a perfect square, so it's 2. And now, just like the previous video, I have 2 things that I have to evaluate. Either it's going to be x equals negative 4 plus 2 over 6, or it's going to be x equals negative 4 minus 2 over 6. And then I work this out. This is going to give me negative 2 over 6, or negative 1/3 if I simplify. And this is going to give me negative 6 over 6, or negative 1. So now I know that my two solutions are negative 1/3 and negative 1. Again, just like the previous video, check these by plugging them into the original equation and make sure that the two sides balance out. Another way to verify is to do this graphically. Plug this side into y1, plug 0 into y2, look at their intersection points, or in other words, their x-intercepts, where it crosses the x-axis, and it should cross the x-axis at x equals negative 1/3 and x equals negative 1. So you've got a bunch of different ways to verify this. So that's using the quadratic formula. Now I want to talk about this piece that I recommended that you evaluate first, underneath the square root sign. Turns out that that piece is called the discriminant. So this is a vocabulary word. So that b squared minus 4ac, just the part that's underneath the radical, so not including the radical, not including the square root sign, just the b squared minus 4ac. That's called the discriminant. The sign of the discriminant tells you whether it's going to be not touching the x-axis at all, only the touching the x-axis once, or touching the x-axis twice. And if you don't remember from a previous video, I showed you these different orientations. There is the possibility that the parabolas will never cross the x-axis. These two have no x-intercepts. These have one, okay? They only touch the x-axis once, and these touch the x-axis twice. So this is how we're going to determine which of these scenarios we have, is by using the discriminant. So these notes, by the way, are in Blackboard, so you have access to these notes. And here's a quick summary in a table. If the discriminant is less than 0, meaning the discriminant is negative, so we can write that too, discriminant is negative, that means that there will be no solutions to ax squared plus bx plus c equals 0. Or in other words, the graph will not touch the x-axis at all. If the discriminant equals 0, so if it is 0, there will be one solution. The graph is only going to touch the x-axis one time. And if the discriminant is larger than 0, meaning that the discriminant is positive, then you will have two solutions, or the graph will cross the x-axis 2 times. So in the example that we just did, we have 2 solutions, which means that this is going to have 2 x-intercepts. And notice what the discriminant was. The discriminant was 4, positive 4, and it resulted in 2 solutions. So let's look at another example to see how the other ones would come out. Now let's use the quadratic formula to find the x-intercepts of f of x equals x squared minus 10x plus 25. And we'll just be really specific. We want to use, so using the quadratic formula. There are other ways to do this one. It actually can be factored. So if you wanted to try factoring this, be my guest. All right, so the more you write and recite, the better you will be at the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Identify your a, b, and c. The a is 1 here, b is negative 10, and c is 25. So this will be x equals negative 10. Okay, this is why parentheses are going to be so helpful. Plus or minus the square root of negative 10 squared minus 4 times 1 times 25, all over 2 times 1. We're going to evaluate the discriminant first, okay? So underneath the square root first, x equals, minus becomes plus anyway, so positive 10, plus or minus. When I evaluate this discriminant, I'm going to get 100 minus 100, which is 0. What do we already know based off of our chart about the discriminant? If the discriminant turns out to be 0, we're supposed to only get one solution. So I can already anticipate what's going to happen. Let's see if that comes out. Since this is 0, that whole thing goes to 0. And all I'm left with is 10 over 2, which is 5. There's only one solution to this. But notice what it was asking this time. It wasn't just asking for solutions, it was asking for the x-intercept. So now I have to write my x-intercept as an ordered pair. So I just found that the point 50 will be the x-intercept. Let's actually check this one on our graphing calculator. So in y1, I'm going to put the original function, which was x squared minus 10x plus 25. I know that this y-intercept is going to be 0, 25. So when I set my window, I'm going to go from negative 10 to 10 on my x. And I'm going to go from negative 10 to, I don't know, let's say 30, because I know I want to see 25. And then I'm going to hit graph. Here comes the parabola. Now I could shift it over a little, okay, to be able to see what I need to see, but I'm seeing enough. I see the y-intercept, I see the vertex, I see the curve. I'm good. It turns out that my vertex is my x-intercept. So do I have only one of them? Yeah, I do. And it happens to be 5. And I can find that 2 different ways. Because I see that it's the vertex, I could either find the minimum, or I could use the process of finding the x-intercepts, which would be to plug 0 in for y2. So this way it draws in the 0 line. And then going to second trace and trusty number 5 intersect to verify that that is in fact where these two graphs intersect. And look at that, I get 5. And we talked about this on Zoom, 0.000028. This is way too small to be of any significance. This is the calculator's error in how it's approximating this answer. So you're going to be smart and you're going to ignore those zeros. That's not part of this answer. It's going to be x equals 5. So it'll be the point 5 comma 0, and it verifies what we got using the quadratic formula. So that's just some support. But we can see that the discriminant was equal to 0, and we wound up with only one answer. Okay, next example. Solve 3x squared plus 10x equals 9 by hand. This one poses a little bit of a problem because I know that the quadratic formula only works when the quadratic equals 0. Okay, and maybe we should even write that so that you have it in your notes. The quadratic formula can only be used when the quadratic equals 0. I don't have that here. I don't have it equal to 0. Right now it's equal to 9. But can I fix that? Sure I can. I could make this equal 0 if I subtract 9 from both sides. So if I do that, I have 3x squared plus 10x minus 9 equals 0. And that's what I need to be able to use the quadratic formula. For that matter, even factoring, if this was able to be factored. Okay, this one actually can't be factored. So we're going to just go for the quadratic formula anyway. So write and recite. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Your a is 3, your b is 10, and your c is negative 9. And then you plug in accordingly. So this is going to be negative 10 plus or minus the square root of 10 squared minus 4 times 3 times negative 9 all over 2 times 3. Evaluate your discriminant first. So I want to put 10 squared minus 4 times 3 times negative 9 in my calculator. When I do that, I get negative 10 plus or minus the square root of 208 all over 6. My discriminant comes out positive, so I know there's going to be 2 solutions to this. So this is going to be my exact solutions. I don't have to do anything else with this. I could leave it just like that. And then if you wanted to get your approximate solutions, you would have to put this in your calculator. But as from the previous video, if you're going to put this in your calculator in one shot, you're going to have to put the whole numerator in parentheses and then divide by 6 if you're going to do it in your calculator. And you're going to have to do these one at a time. So either plus, then do it, or then do it again with minus, okay? If you evaluate each of these in your graphing calculator correctly, you should get x is approximately negative 4.0704, and x is approximately 0.7370. If you were going to check this graphically, you would go to the original problem. You would put this side in y1. You would put this side in y2. You can do that for any equation that you want to check graphically. So let's do that. In y1, I'm going to put 3x squared plus 10x. And in y2, I'm going to put 9. I'm going to bring this back down to a standard window. And to do that quickly, I can go to zoom 6, takes me back to standard. So I can just hit number 6. And it'll take me back to a window of negative 10 to 10. I do see the parabola, and I do see the line being drawn at 9. That's what I want. I want to find these 2 intersection points. So I'm going to go to second trace, number 5. Go to one of those intersection points. I'll just go to the first one. Follow the prompts, and look at that. Negative 4.0704. Negative 4.0704, just like I said. So that verifies, and you can find the other one. I won't do that here. Okay, you can determine that the other one is true also. So there's the quadratic formula. We had 2 solutions, not the prettiest solutions, but that's okay. We know how to work them out. And then last but not least, one last example using the quadratic formula. Find the x-intercepts of the function f of x equals 2 times x squared plus 2 plus 3x. Well, this doesn't look anything like the examples that we've had before, because this is not our beautiful ax squared plus bx plus c. I have to do a little bit of manipulation here first. First, I'm going to distribute the 2. So I get f of x equals 2x squared plus 4 plus 3x. But now I notice that it's not written in the right order. I need it to go in descending order, so I've got to swap these. So it's going to be f of x equals 2x squared plus 3x plus 4. And before I do anything, I'm going to go back to the question and look to see what it's asking me to do. I want to find x-intercepts. X-intercepts occur when y equals 0. So what they're asking me to solve is 0 equals 2x squared plus 3x plus 4. And now I'm going to use the quadratic formula, because the quadratic formula can be used when the function equals 0. So write and recite x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Identify your a, b, and c. Plug them in. So this is going to be x equals negative 3 plus or minus the square root of 3 squared minus 4 times 2 times 4 all over 2 times 2. Remember, discriminant first, okay? So you don't want to do this whole thing in one chunk. Do the discriminant first because it gives you information. This is going to be x equals negative 3 plus or minus the square root. This is going to be a negative number because it's going to be negative 23 if you were to put this into your calculator. That's the problem, because can I take the square root of a negative number? Absolutely not. And so when we go back to these notes about the discriminant, if the discriminant is negative, there's going to be no solutions because I can't take the square root of a negative number. Doesn't make any sense. So when I get here, I don't have to go any further. The discriminant is negative. And so I can say that this is going to have no x-intercepts because it was asking me about x-intercepts, so I'm talking about x-intercepts. There will be no x-intercepts here, or in other words, this equation has no solutions. And you can verify this by putting the original function into your calculator and observing that it does not cross the x-axis. If it doesn't cross the x-axis, then you will have no x-intercepts. So I wanted to put a few synonyms down that you might see in a variety of problems. So these are all basically synonyms, give or take, okay? There's some slight differences. If you see the word zeros, okay? If you see them ask for solutions to ax squared plus bx plus c equals 0. If you see them ask for roots, or if you hear them or see them ask for x-intercepts, they're all asking you essentially to go through the same process, except x-intercepts must be written as ordered pairs. That's the only difference. So each of these, they're just really looking for solutions, but when they say x-intercepts, they are looking for the points on the graph, so they should be written as ordered pairs. But essentially, these are all asking you to do the same type of work. All right, so now you have the quadratic formula. Make sure you're practicing and contact me with any questions. Take care.